You go to start 2.5, Archimedes Principle. Hopefully you prepare the notes already. Go through the notes. First one, the spelling must be correct. Archimedes Principle. Remember, this one is a S, after that baru apostrophe. Now we're going to see what is Archimedes Principle. Let's see the sum of the situation. Two pieces of the plasticine, same mass, 两个 mass 是一样的啊。When both placed inside the container with the water, plasticine B, P, they are sink. Another one should be floating. How does this one situation occur? What conclusion you can make it? The conclusion is, you can say, oh, maybe the plasticine P, they are more heavier. That's why they sink a bit inside the water, okay, compared to the plasticine Q. Something like this. This one is by observation. From here, we go and see this one question. There's one of the aim to discuss the buoyant force. One of the force we call buoyant force on an object immersed in the liquid. So that means when you just immerse the object, example, container. Fill full a container with the water, then push an empty mineral water into the water slowly. 空罐子放进去一个 container with water. And you just push the bottle go in. Do you feel any force when the bottle just push downwards? Sure, you can feel. From here, state the direction of the forces. I want to ask Bong Shu Qing. What do you think about the direction of the forces? Downwards. Downwards 的话，这样你的 bottle 不是全部沉下去哦。Now I'm talking about the water forces, not the bottle forces. Water you press. That one is the forces you go to press. But when you press down, you find it the water is very hard to go down. Something to lift up. So you think about the direction of the force. This one force is acting from the water in the container. 不是你的 bottle, 是你压的 force 一定是向下的。但是你发觉到 water 里面有一个 force 一直不要给你下去 that one the force pushing upwards. From here the first one, do you feel? Sure we can feel lah. State the direction. The direction is acting upwards. It's a water that acting the force go upwards. Now we continue. When you push the bottle deeper, 你还继续压 what happened to the force? The force keep be increasing. 你越压它越低，你会感觉到那个 force 会更强的推回你上来。The force will be increased. A volume of water display. Volume of water come up. Okay, 小恩 what do you think the answer for number 2? Increase. 你越压越低，肯定understood. 它的 volume 的属于肯定会导更多的出来。So volume display also increase. Now we're going to see number 3. State the relationship. Now we do the just now we mentioned about the force and also volume. Now we do some relationship. Okay, related between the buoyant force. This one force should be the buoyant force lah, acting on the bottle and the volume of water display. Okay, suppose it's both also increase because we don't have any formula to prove it. We just say when the buoyant force increase. Okay, when the buoyant force increase. You write the full name, buoyance, buoyancy, B-U-O-Y-A-N-T. Many students, they write B-O-U. B-O-U is wrong. B-U-O. When the buoyant force increase, volume of water display also increase. This one you can say inversely proportional, directly proportional because we got formula. We got formula to prove it one. So starting before we go to prove the formula, we just say when both also can. You want to when also can. You want to say buoyant force directly proportional with the volume also can. What will happen to the bottle when you release your hand? So just release your hand, the bottle must be up, is it? So from here you can find it, then move, bottle, move upwards. So from here you can see very clear what is the buoyant force. We cannot see the force, but we can feel that what is the force acting in the water, acting upthrust, go up. So now we're going to see the second situation. Now a piece of the stone that's with the string that hang on the hook of the spring balance. This one is a spring balance. Spring balance show the reading must be Newton. Measure and recorded the weight of the stone in the A. First one, that means you're not yet put inside the liquid. Not yet put inside the liquid. From here, this one spring balance, so we assume the G is a 10. So be 50 Newton. So now this one is in the A before you go in. From here, we don't have any buoyant force to acting for you. We only got one of the forces acting downward. That one is the mg. Measure and recorded the weight of the stone. So from here, we find it the weight of the stone, W1, there's a 50 Newton. If I take the G is a 10. Second one, the weight of the slaughter weight when I just put inside the water. You can see my whole slaughter weight muscle all go in. So now the reading they show 3. They show 3, so I change become the Newton, 30 Newton. Now you can find it. 20 Newton, where to go? 20 Newton means you sure got one of the weight is go down, one of the force go down, that one is mg. I sure got another forces acting upwards. So acting upwards, they put negative. That's why you can take with plus, then minus, how many? 30. And you can get the answer, 20. So that's a one of the, 20 and minus 20, this one 30. So reading here is a 30 Newton. From here, this one's a one of the forces acting from the water, but in opposite direction. This one forces, we call it as a buoyant force. Now we need to compare W1 and W2. So Friday W1 is more than W2. What conclusion can you make about the weight? Friday, the conclusion is weight of object in water is lower. It's lower than because of the due to the buoyant. And the object you just put inside the liquid, they got one of the force to pull up. So just pull up, that means you can find it, the reading become less. Example, you pull something in the sea. For the fisherman, they want to pull the net together with the fish. So in the water, when they just pull, when the net in the water, they go to pull, it's just simple because some of the force to lift the net up. So you just finish. That means you want to come out or you come out from the water, you find it very heavy to pull it because your buoyant force become less and less. So for become less, so find there's an original weight already shown. So find it then more heavier. Before that, just only the introduction, what is the buoyant force? Because we cannot see. We're only using substitution to feel it, what is the buoyant force. Now we see this part. The cylindrical object is completely they put inside the water, immersed in the water. Now we compare the height. Compare the depth of the top face and also the bottom face. We find it H2 sure more than H1. The depth is a different.
M 考试即将来临，你是否感到焦虑？因为感觉自己的进度落后了。在课堂上，你全神贯注，但有时候听不懂老师在说什么，特别是中4、中5的物理课。别担心，你并不孤单。现在，你急需一位既有经验又懂得用心教学的老师，而且这位老师还能流利使用华语进行沟通，让语言不再是阻碍你取得好成绩的障碍。幸运的是，我们正好有这样的物理老师，他拥有多年的教学经验，并且在 YouTube 上有自己的频道，全马来西亚的学生都可以从他的课程中受益。如果你真的想要学好物理，那么不要错过这个线上 SPM 物理课的机会。通过这个平台，你可以更快地掌握和学习物理知识，为 SPM 考试做好充分的准备，最终取得令人瞩目的成绩。别犹豫了，赶快行动吧！与这位经验丰富的物理老师一起学习，让学习变得更加高效和有趣。相信自己，你一定能够在 SPM 考试中取得优异的成绩。
I'll continue. You're talking about that is a different. So pressure also different. The pressure depends for the depth. Surface is a P1. Bottom is a P2. Now they want you to compare. P2 is more than P1. Sure. Alright. Because pressure increase depends as the depth increase. So depend for the depth lah. Now we compare about the force. Force acting at the top surface with the force at the bottom surface of the cylinder. So mean this one is the cylinder surface. Force acting up. This one is the top. Force acting bottom. So I want you to compare. So force acting. So pressure, force over area. Now the area already constant. So then you say the pressure increase. So force automatically increase lah. So here I can find it. The force at the top or less than the force on the bottom. So here we can find it the bottom, the forces acting should be high. I mean that just like just now the diagram, the mineral water, when you go down some more, you find it the lagi hard to push the bottle go down. Because when you just go down some more, the force keep increasing. Now, what is the direction of the resultant force? resultant force. Just now we're talking about the bottom is bigger forces. Up is a less forces. The resultant force is acting where? Must be acting up. Just like this one diagram. You see this one diagram. This one's acting upwards, downwards to the surface of the top. This one is another forces acting the downwards bottom surface. From here, I find it this one force is bigger. This one force is less. So finally, the resultant force go where? Should go up because the bottom is higher, you minus the smaller. So finally, the resultant force go upwards. So the answer, resultant force acting upwards. Name the resultant force. Finally, this one resultant force we call what name? They call buoyant force. Remember, buoyant force always acting upwards, opposite the direction with the weight. Now we need to go definition. Remember the definition every time you ask before you want to answer the question, bottom question. This one is the first one. They will give you the definition first, 1 mark only. Although it's 1 mark, you need to write the full definition. Then the following maybe is compare, maybe is call you to modify, or something like this. So the first one related with the topic, the whole topic is the same one. Example, momentum. They ask momentum. The whole thing is a momentum. Sure, the first one will ask you what means of momentum or something related momentum, velocity, mass also can. So definition, I cannot say there are so many definitions we don't memorize, cannot. But certain definition that never follow the formula you need to memorize. Okay, follow the formula is a momentum, velocity, acceleration. But example for the buoyant force. Buoyant force, they never follow the formula. So to keyword, get the keyword, join the sentence. Let's see here the buoyant force. Buoyant force is the force. Okay, there's a is the force. Acting, I say where they're acting upwards. They're acting upwards on an object. Emerge. The object emerge in is either you say A, either you say B. Because it's force acting upward on an object when immersed in a fluid. There is pressure different. As pressure different because we got up and down between the lower surface and upper surface. Oh, I give you long already. Later you see longer. First, upper surface an object. You don't need to write this part the pressure different surface. Just the right point. Buoyant force is a force acting upwards on an object where it immersed in the fluid actually until here already enough. Okay. This one, why I put the pressure, because I want to relate it with the diagram. Okay, we until this part when immersed in the fluid, that enough already. So the pressure different. Why got pressure different? I want to show this one diagram. Because one is acting upwards, another one is the bottom. So of the depth, so pressure different. Now, after we finish this one, you find the keyword you need to mention when you just put the definition. This one, acting upwards. Acting upwards. This word must have immerse in fluid. This one must have either gas. Either gas mean we're talking about the hot air balloon. Say about the liquid, so liquid. Anything just put inside the liquid. Finish for the some introduction about the buoyant force. Now we need to create formula. What formula for buoyant force? Come, let's see the create formula. P1, pressure acting on the top of the surface. Now we go and see what's the formula. P over A. This is a normal formula for pressure. I want to find pressure acting. So formula for liquid, there's a H rho G. This one we learned before for the liquid. So the situation in the liquid. So put H is the top, is it H1? Then rho is a water rho, then G. This one is for the pressure one. So next, acting how? Forces acting in the here. This one you say the pressure, this one. So here I need to write P1. I want to find F1. P multiply. But this one is a P1. P1 refer here one. They also refer H1 rho G just down only. This one is a P1 equal. This one is a F1 equal. So I also can write like this. Now we go to second one, to P2. P2 again, same like just now, P2 equal H2 rho. Now I want to find 2. 2 same like just now, F2 equal P2. Put in the P2 will become equal to rho. Now we got this one, this one. Okay, we got two forces. Now I want to find resultant force. Just now you say the resultant force acting upwards. So you know, because I take resultant force equal F2 minus F1. because F2 is bigger. Because the depth increase, the force downward should be higher compared to the at the top surface. So I go to minus, so it come P1, P is a rho, is it? This one is F1 and F2, these two things. So the F2 minus, so GA, I copy this one, minus rho GA. Next, I continue. Okay, I take out the rho GA, it's the same thing. Rho is a liquid density, G is 9.81. A surface up and down is the same. Just only different is a H2 minus H1. H2 finally still H like, is it? One of the number, but we label there's a H. So G finally after minus they become H. I want you to concentrate this one. What's the AH? AH mention dimension not here. What's the AH?
都是 volume
Volume. 十一懂吗 ？AH 是 volume。
真的不懂
因为 A 是 area 吗 ？H 是 height。
知道好像。
So the volume is area multiply the height multiply some more width. So AH. Sorry, not area. This one is a long height. So after that, when you multiply either one, they become area. Then area multiply the height, they become volume. So finally, I can create this one is a V already. This one is a VH. So I say V rho is a formula for buoyant force. Liquid pressure rho. Therefore, is V. And liquid pressure is related with the depth. After that, for buoyant force related to the volume of liquid display. I want to explain rho G is siapa punya V, siapa punya rho, and siapa punya G. So two things. One object, because object put inside the water. Another one is the water come out. So two of the things. Careful. Many students misunderstand. Oh, density is object one. Volume is an object one. No. This one called it as a weight of liquid display. All the thing in liquid. 出来的水到底有多少 weight? What we call weight of liquid display. The return force, that's a buoyant force, FB. So force also can say there's a resultant force acting upwards. So finally, we can write the formula V rho. You explain. Density of liquid display. All the thing is a liquid, not related with the object. Volume is volume of liquid display. Also liquid display. What situation volume of the object will equal volume of the liquid display? 谁可以跟我讲这个东西？ You go to five size one monitor. 先总
沉在水里面的东西。
我很多情况是沉在水里面的，我沉一半也叫做沉，我沉整个也叫做沉，不沉整个震下去也叫做跌下去。说什么情况 VO 会等于 V 的沉到完？ So not every time the volume object same like the volume liquid display. 如果我放一半呢，我只是给它浸在水里面一半呢 ，volume object 肯定是大过 volume liquid display， 因为你只放一半嘛，出来的水肯定是一半啊。So 什么情况我可以用 volume object 也是 volume of liquid display， 整个 object 都已经下去了啊，那个才可以用。From here the objects emerge in the liquid equal， 这个是记得 volume of the liquid 是 for V rho G， so volume of the object 只是那一 part 沉在水里面那个叫做 volume of the object， 要 make sure 整个 object 已经进去了才可以用。So everybody know gravitational acceleration. If the question never mentioned, still using 9.81. This one is the value for the gravitational acceleration. Now we go to Archimedes Principle. Just now it's a buoyant force. Now it's the Archimedes Principle. So Archimedes Principle, they're talking about buoyant force. That's the overall. We still using principle 因为 principle 是最大的 Archimedes 还是 under 里面罢了 Archimedes Principle buoyant force equal weight of liquid display is 是 display BLACD 对volume of liquid display. So 他讲的东西就是这个咯 FB equal V rho G this one is Archimedes Principle. Buoyant force equal weight of liquid display. 他要讲的其实就是这个 formula. But when they ask about Archimedes Principle, you cannot write equation. You need to write the words. Volume of liquid display. Weight of liquid display. So one is Archimedes Principle. So when the question gives you of the diagram, the water, the box put inside the water. Then after that, force acting. So ask you what's the principle. So it mentioned Archimedes Principle. So the following object will experience force of the weight. due to the buoyant force. When they just put inside the water, they find it the weight become lost. So of the buoyant force, the weight of the object in the water lighter than the actual weight in the air. Sure, lor, because buoyant force support already, ma. So then you find the object in the water, they become lighter a bit. Number three, actually they want to tell you how to find buoyant force. Weight of the object in A. Example, just now we show the hanging for the spring balance, 50 Newton. Is it? So we put inside the water, they become 30 Newton. 20 Newton go where already? Suppose the formula is B buoyant force equal actual weight 50 minus apparent weight. This one we call apparent weight. Apparent weight 就是假假的 weight. So you put inside already that what we call apparent weight. So apparent weight is a 30. So buoyant force is 20 Newton. So that's one of the simple formula to find buoyant force. When they just show you about the diagram for the spring balance. Now we see the activity 2. Relationship, the volume of the object image and also the volume of the liquid display. Sure, directly proportional one. So you just put inside one of the finger, you find the water level up a bit. 2 finger up more. The whole hand you put inside the liquid, or the liquid already come. So like this, we find it the volume display and also the volume of the object you immerse directly proportional. You immerse more, then the volume come up should be more. So here the first one, what will happen to the water level? So water level increase. And you just put inside your hand. An object will display this view done. An object will display a liquid when it is immersed in water. So example, before I put in the apple, the volume of the water is 500 cube. So just put the water in already, I find it becomes 700. So here volume display is how many? Volume display is a 200 cube. So volume of the apple immersed is how many? Also 200. So the water come out 200. If I put the pipe here, the water come out sure 200. Then this part, the volume how many? There also is 200. So this we call volume of the object display. So conclusion is volume of water displays equal volume of object image in water. So make volume displays from the object when you just put inside, the water come out is how many? They're exactly same like the volume of the object you immerse in the water. Now this one got one experiment we need to do when you go back to the school. Let's see this one example, the quite simple one, understanding. So first one, spring balance, they show 25 Newton. That means the weight in the air, normal weight is a 25 Newton. When the weight of the stone put inside to the liquid already, you find it, they become less. So now we call apparent weight. Apparent weight. So want to find the loss of the weight. The loss, how many? We take 25 minus 15. So I get it just a 10 Newton. So 10 Newton we call what name? We call buoyant. For me, they got one of the force acting upwards with 10 Newton. Number 4, this one is one of the experiments you need to do in the school. So I refer first to determine the relationship between the weight of the water displaced and the buoyant force. We want to find what's the relationship. Weight of the water and buoyant force is the same, also is a Newton one, because weight also is a Newton. So in the plate variable, we only can control is the slotted weight. The diagram like this. Then you hang the slotted weight on the spring balance. After that, you slowly put inside the Eureka can. This one is called Eureka can because they got one of the tube to let the water to come up. So B, first one we put weight, third weight. Next one responding is buoyant force. Later the buoyant force, you can refer the measurement here. 0G, we calculate the buoyant force. Constant, what should be constant? Liquid must be constant because they're related with rho, related with the G. But normally we mention about the rho lah. We don't mention about the G. From here is the density of liquid. Now put the water, so Eureka can till it flow out the water. So put more first, let it to flow out. Flow until this level that stop. Now weight empty. So one beaker you go to measure what is the mass when it just empty under the part of the Eureka can. Now suspended the load using the plasticity at the hook of the balance by about the weight in the A. So when starting you hanging this one in the A, you go to measure. Measure first because before you put inside the water, what is the actual. Next one, you also go to measure the beaker, empty beaker, how many mass. This one is a before we do. So here I prepare a table also for you to answer it. Later you lower the plastic into the eureka. Slowly to lower, part by part to lower. When you just lower, you can find the liquid slowly to come up the beaker. So finally, completely immerse. I miss complete immerse, not this one is this one is the beaker. Yeah, I call it to completely immerse is like this. I never say this one already support by the beaker. The only complete immerse is still hanging. They're still in the water, but not yet support by the beaker. So we call completely submerged. So when there's no more water flowing out from the spool, after that you can find the weight of the beaker and water display. So find these two things. First one, this one is a before you need to do. This one I label, there's a later we got answer it. This one is a part B. This one is a part C. Later bottom you need to answer it. First one example, I mentioned that. Example, the first one, before you go to put the liquid inside, put the plastic in the water, you just put in the A, you measure the normal. I get it 2.2 Newton. Then I put the plastic in the water. So I just put inside the water, I find it, they become 2.0. So this is how many? Buoyant force also 0 Newton. This one is talking about plastic. Plastic. And now C, we're talking about mass of the empty beaker. Before that, the beaker, you go to measure how many kg. Kg too big already. Gram. Change the gram first. Measure, maybe I get it 11.0 gram. After that, I put the water. So water will come out, is it? I go to measure. So already, all the object already complete in. The water all come out already, no more already. So I will take the beaker, you go to measure again. So I get it 31.0. So mass of the water is how many? So I go to minus lah. I get it as a how many? 20 gram. So from here, because Newton, I need to convert. So T gram you convert become Newton, you divide by 100. I assume the G is a 10. So I take 20 divided by 100. So I get 0. So for your experiment, you need to prove it, buoyant force, and also the weight of liquid display is exactly the number. So to prove Archimedes Principle, so B must equal B. So that's what we do. Just go back to school. Now we go and conclude again. Object in the A, actual weight. Because weight, there's a 2.2. Object submerged in the liquid, that means that's called apparent weight. There's a 2.0 Newton. Now the object already display, or they put inside already. Now the volume of liquid display. This one volume of liquid display. Same like volume of the submerged part of the object. I also can say now this one is a volume. This one you call it volume object. So let's say VO now equal V. You got here or not? Never enter. Yes or no? So no. How we call Kelvin? VO equal V for this one situation. Yes or no? Your answer yes. Don't answer yes. So object fully immerse. If they're just halfway, we cannot say VO equal VW. We only can say volume of the object, volume of liquid display, the water submerged part of the object, submerged part. So submerged part maybe halfway, full way also can, but you must measure submerged part. Now the D, object experience apparent loss in weight. Now they eat the weight object in A minus weight object in the liquid. So you want to find the buoyant force, you need to minus actual minus apparent. So diagram B, diagram B is this part, this one B. The whole thing we label B. So diagram B is how many? Diagram B, I find it 0.2. Buoyant force is 0.2 Newton. Diagram, the next one is C. Diagram C is the bottom part. Bottom part, I also the weight of liquid display, also 0.2. So here, buoyant force on object, same like the weight of liquid display. So just want to prove Archimedes lah. But normally when you do experiment, we cannot get the perfect one. And maybe the water stick on the Eureka can, they cannot come out. Like this also affected our weight of liquid display. So we not get a perfect answer. Buoyant force you measure by balance of simple. Then the spring balance show you the reading. But you want to let the volume of the water come out, that will hard a bit. Because sometimes we got pressure surrounded, we got air resistance. They also will affect the quantity of the water to come out. Okay, we're going to see this one. Buoyant force actually is what? Buoyant force is a weight of liquid displays. Okay, you also can say buoyant force equal apparent loss in. Okay, normally it's the first one. Okay, the first one. Also can see buoyant force is B. This one is formula. Okay, so we unpick question. 来，有问题的现在问。Shermaine Jin, anything you want to ask?
Nothing.
Oh, nothing 哦。听
No.
有吗？伟人没有。林 Brian 怎么有没有在的？Brian Lim Di Hang here or not? Brian Lim Di Hang ada. They say on the highway want to online. Mana ada? Okay, we will see the question. When you do the example, then you know you understand or not understand. Okay, so you start one. Example one. Okay, see the example one. Okay, take the G is a 9.8. We take standard one. Okay, now the one of the sphere has volume. Okay, tell you the volume of object 5 times 10 power negative 4. Okay, the cube. Okay, in the water, then that water density, you must really be careful. This one density is a water. They never say object density. They say immerse in water of density. So the water density, water 1000. Determine the upthrust experienced by the sphere. Okay, thrust. So Archimedes principle, buoyant force, that means upthrust lah. The acting up. So that's your buoyant force is how many? So Archimedes principle, buoyant force equal rho. Okay, here we need to know B. Okay, the question never matters how many emerge. So let's assume there's a big muscle. Okay, the question want to tell you that so how many, they will tell you. The halfly volume emerge in the liquid is how many, something like this. If the question never mentioned, they just tell you, okay, the object volume is high. So assume, everything we assume everything go in. So the volume we just take VO, so 5 times 10 power of the negative 4. Okay, city liquid, the B is a volume liquid. Because the ngam same like the VO, so we take it as a 5 times 10 power negative 4. Okay, city, I want the liquid density, then multiply 9.81. Okay, this was okay, 4.90 filtered. Okay, so that is a buoyance. Okay, but then we go to question 2. Okay, question number 2. So they say a wooden block, block with the density block. So density object 4 times 10 power 3. Okay, 3. Okay, and mass object 5 kg. Okay, immerse in the liquid. Okay, we say immerse how many? We just assume everything go in. Okay, density of the liquid density 1000. Okay, calculate the buoyant force acting on the wooden block. Okay, the same thing, B zero G. Okay, don't forget this one is liquid punya zero G. Okay, now the question not exactly give you volume. They give you the density and give you the mass. So from here, you need to find density object equal mass object over volume object. So find the VO first. After find the VO, then you put in. After that, we do calculation. So situation also same. VO equal V liquid. Whole thing go in. So one the answer. Okay, here I want the answer from eating. You find VO first, object volume. After find the object volume, then you baru find the buoyant force. Okay, you find the V first. Anybody you just find, you can type in the chat already. Monitor, then 找到你就快点 type 进去啊。We find the V first. From here, the V I get it is how many? 1.25 times 10 power negative 3. Okay, 2.12.265. Okay, so buoyant force. So find the volume first. Okay, after that, baru you apply. Okay, correct. Okay, continue. Okay, 3. An object has a weight object, 40 Newton. Okay, now in the A become 36. Apparent weight lah. So this one's the actual weight. Apparent actual equal 1. Okay, write the different word. Don't write the same word. So you go to label by different of the symbol. So here I want actual weight. 40. Here apparent weight. There's a 36. So the liquid density liquid 800. So determine the volume of the object when in the liquid. So here we valid buoyant force first. Buoyant force how to find? 40 minus 36. So get 4 Newton. 4 Newton actually is a V rho G. Follow Archimedes principle. So here volume of the object in the liquid. So here this one situation, the whole thing means object already go in. So why they want to find the volume object. Okay, I mean the volume of the object in the liquid. Okay, one going also can because the question says volume of the object when in the liquid. Maybe halfway lah. How? Because we don't know, but I know this one V rho G sure liquid one. Okay, liquid punya. So V also stand for volume liquid come up. So the person say, I want to know volume object image. Okay, object image, same like the volume of the liquid. So I want to find V. Okay, so here answer from, so you go and type there, so so we find the answer for the volume of the object image. Okay, 5 point times 10 power -4. Okay, that is a V. The volume of the liquid display. You also can say the volume of the object image in the liquid. Okay, see example 4. Example 4 got diagram. Why they move so much? So here you can see the question. An object is hung from a spring. So now an object is hung from a spring. Okay, that's the question. So what is the buoyant force of the object in the water? So the force 65 minus 30. Then you get the answer. Okay, answer A. B is equal 65 minus 30. So I can define it. The time is my buoyant force. Okay, so what is the weight of the water displayed by the object? Weight of water display, same like the buoyant force. Follow the Archimedes principle. So I don't need to do any calculation. I'm straightforward to write 35. 35. Okay, C. Determine the volume of the water displayed by the object. Okay, volume of water displayed. So object go in, is it? So we find the volume of the water first. So I know 35 equal V rho G. Okay, this one water one. So I want to find V only. So from here, I want to know the V is how many. Okay, here I want to call Waren. Give me the answer for V.
3.568乘以 10 to the power of -3.
Okay, is the volume of the liquid display. Okay, D. What is the volume of the object? Volume of the object. Lim Shiyu, volume of object.
不叫我，
来，答案。
我还没有算那样快，你叫别人先啊。
不用算的，我直接跟你讲一个东西。刚才那个是3.568，对吗？
对，3.568。
诚实保证3 OK， 好，他问你 What is the volume object？ 你看 diagram 是不是整个东西进去了 ？Volume object 应该多少呢？刚才是 volume liquid come out， 总共 volume 的水出来，总共的水
same，
所以应该是 same， 所以你要写回同样的答案 ，OK， 都不需要算的 ，OK。OK， now let's see example 5. Okay, example 5 actually is an application already. Relationship between the equilibrium of the forces and also state the flotation of an object in the liquid. For example 5, 现在我们要讲的东西是 floating. Archimedes Principle don't care floating. When you just put inside the liquid, we say Archimedes Principle. Okay, now we go specific a bit. I want float when the object is float. So the object is float, we got so many different patterns. Okay, this we call floating. Okay, this we also call floating. Okay, this also call floating. So the object never sink until down, that one we call floating. Floating stationary, that means they no move, already float. Okay, starting, you throw the object come down. When you throw the object come down, sure, they go down first lah. Okay, let's go down first one. Okay, down first. Later, you find it, if their density is low, later they will up. Later they up, finally you see what happened for the object. Is it the object just go down, then they never up, and that one called sink. That one is weight more than buoyant force. Okay, I just threw, you cannot say, oh, make a conclusion, you didn't know. The process, when you just threw, the weight is more than buoyant force because they go down. Okay, slowly you find the buoyant force already acting to the object. And you see the buoyant force strong enough or not. If strong enough, they can push the object up. When it just up like this, halfway, not yet surface, still the bottom, this one also called floating. Okay, this situation, we call it buoyant force equal up halfway, up and down. Okay, situation, we also can say FB equal, this one also same, B equal, this one also same, unless like this one no. This one is weight more than B. Okay, floating, you must remember floating, weight equal W. That's why the object can float. Okay, you don't have buoyant force more than weight. Buoyant force more than weight is when the situation you threw, then you slowly up, that one we say buoyant force more than weight. Until certain situation they stop already, okay, buoyant force equal W. Don't tell me until the buoyant force outside very large, until the object full up, go up, like the water fountain, no. Okay, don't have that one situation. We just got the object go down, sink, force, the weight more than buoyant force. Okay, then when the object up, okay, buoyant force more than weight. Okay, stop, buoyant force equal weight when it's just floating. So they got so many different situations. I don't know you how to float lah. Sure, the object halfway water, halfway up. also fall. For this one, holding at the middle one, not yet until bottom, just the middle, we also say floating. Okay, here we want to see when floating, the object already stationary. Okay, stationary means up, down is balanced already. So example the object like this. This one we call equilibrium. Equilibrium means up we got buoyant force, down we got weight of the object. So both up, down also balance. Okay, offshore is a mg law, upshore is a buoyant force. So here these objects are floating stationary. When it just says stationary, understood, resultant force equals 0. Okay, we need to mention two forces acting to the object. So for sure is a weight. Okay, the one is a buoyant force. Okay, it's the relationship between two objects. When stationary, both equal. Okay, it's equal. Okay, you can see this one also is a floating. And you see this one's a hydro. Measure density, called one name already, hydrometer. The one is measure the density of the liquid. You can see the tube floating. Hot air balloon also floating. So now it's just related with this one's an air display. This one's a liquid. So both also is a floating situation. Okay, we're going to see this one diagram, number 2. Okay, the apple mass. Okay, mass is a 200 gram lah. Okay, want to change become the weight, you multiply, you change become the kg, then you change become the Newton. So I take the G is a 10, simple for calculation. I get 2 Newton. Okay, 4 put inside the water. So here, mass of an empty beaker. Okay, go to measure the empty beaker first. Example, this one, you got diagram, is it? This one, beaker, how many? 130 gram. Okay, in kg, so 130 gram, can become kg, 0.13 g. Mass of empty beaker plus water, this one, 330 gram. Then change kg, there's a 0.33 kg. Mass of the water display, mass of water display. So of the water display is how many? So the minus lah, 0.33 minus 0.13, I get it 0.20 kg. So this one minus this one. Weight of water display is how many? Weight of water display, you go mass already, so to multiply. Okay, this one is a mass, change become weight. So take 0.2, multiply 10, so I get it 2. So that is a weight of water display. Okay, apple is how many? My apple is also weight of apple 2 Newton. So here what I want to prove, okay, I mentioned again, buoyant force equal V/G, liquid. This one is Archimedes Principle. Okay. Now, floating. You see the apple is floating, is it? So this one example for the experiment that prove it, weight of the object, same like the weight of the liquid display. So here, where float, weight object equal weight of liquid display. So you can say that O equal V. So it's a when floating. Okay, plus together. When floating, I can say 3 equations. Okay, first one, buoyant force 1. It's a sure law, buoyant force. I don't care for the Archimedes principle. I don't care you float, not float. I also can say 1. B equal V/G. If this one situation also floating, I can say the equal weight of object. 3 can combine together. If sink, no, only FB equal V/G. If the object floating, I can find what is the weight of the object by using buoyant force. Okay 吗 ？Okay， 那我们讲的是 floating 了啊。So see the situation first. First one, they want you to compare the weight of the apple and weight of the water display. Okay, compare 两个一样。Apple equal weight water display. Okay, the requirement so that the object can float stationary in the water. 什么情况之下它可以 float stationary？ 就是当你的 weight object equal 你的 weight of the liquid display， 就是你所谓的 V/Rho， 或者是 3 just for floating. So that means we got 2 concepts 啦。Archimedes principle is cover all. They don't care you float lah, you sink lah, you halfway lah. We also can using Archimedes principle. But you want related to the weight of the object, only floating. Now you see first situation. 2 also float lah. Now the W equal FP. W object equal buoyant force. Resultant force 0. Because they're already floating stationary. Force is balanced. Object is stationary for the first situation. Like this also float. Second one also float. Depend how many you go to up, how many you go to down. Second situation, this one halfway, but they got acceleration. They want to continue up already. You throw, they go down. Now they want to up already. This one we said it, W less than buoyant force. This one acceleration up. My citation 2, where is that? Okay, citation 2 first. Citation 2, you see the acceleration come down. See, when I threw the object, it's faster to go down. So I can say now weight is more than buoyant force. Because they got acceleration to come down. Resultant force is go where? Downwards. Resultant force go downwards. Force is unbalanced. Object move downwards with acceleration. Downwards with acceleration. This one is a citation number 2. Citation number 3 is a citation when I just threw already, they come down. After that, they're starting to up already. Before they're floating, they up first. With acceleration, very fast to go up. Now this one citation, I say, now the weight is less than buoyant force already. Resultant force, upwards. Force now also unbalanced. Object move upwards with acceleration. This one is a citation for the object in the water. Either stationary, either they go to sink, either that move up back. This one is a diagram. The following is an application. For the application, I don't want to touch first. I just want to go to the application. About the school, we're going to touch about the application. Now we're going to see the example 5. This one, example 5. Figure show about the line L. Line L is a maximum level. If you're more than line L means already sink. The boat already sink. The volume of the boat below the line is 2.8. This one, only 2.8. The mass of the boat, 600 kg. What is the weight of the maximum load that can be carried by the boat? 它还可以载多少 the mass, the weight of the load without sink. That means I want to make sure the boat still floating. Now the question, they give you density of the liquid and gravitational 9.81. Floating, first one I can write the formula is FB equal 0G. This is Archimedes. Next one, they also equal mg. Object 0G, 3 equations we can use together. Now the question give you the informed volume of this line. So I can find 0G. The buoyant force is how many? So I can put in 2.8. 2.8 already is a maximum. Cannot more than 2.8. So multiply the density of the liquid, 1000, and 9.81. And equal to the mg. So mg is a mass of the boat you need to count. You also need to count the load. I don't know how many load you can put in. I just say 60 kg. Multiply the load 1, then 9.8. So suppose the 9.81 you can cancel each other. Finally, you just want to know they still can bring how many mass of the object. After mass, you convert become. Okay, so from here, Hanshin, you give me the answer. Weight is how many? 2200 kg. 9.81, is it? Okay, so from here, go to minus 2.8. I suppose it's the same, 600. Okay, so cancel, there's a... What my answer? Different one. There's a 2800 minus divide by equal. Oh yeah. Okay, minus 60. 600. Okay, you can bring is a 2200. It's a kg. Is it kg? So after that, you need to convert become Newton. Okay, you calculate just now is kg. Then you convert Newton how many? Okay, just multiply 9.81. So answer is 2152. 2200 multiply 9.8. 2152 Newton. Question asks, what is the weight? Now, example 6. Example 6, floating. The object is floating. A raft is floating on the sea. The mass of the raft, 54 kg. The density of the seawater, density liquid, 1080. Gravitational 9.81. What's the weight of the raft? Weight equal mg. Answer, any low?
529.74.
529.74 Newton. We compare the weight of the raft with the weight of the seawater display. Chin.
Same.
Both equal because they're floating already. So you do any calculation, you just say both equal, both same. Now see, calculate the volume of water displayed by the raft. So you say the buoyant force equal to the weight. So I can write the equation is I bring the mg equal rho-g. So here, this one situation, we cannot say VO equal VL already, because you're floating, you're floating, not the whole object in. So now your VO sure more than. So I want to find is the volume of water display. So G529.74. Volume liquid do know. Density is 1080. 9.81. I just want to know what is the volume of liquid display. Now I want to find Kaching, Chong Kaching. What's the answer for VL? 0.05. The volume 0.05 M. Okay, so that's an example 6. Okay, we go to 7. A safety line to mark on the ship that make sure the load carried by the ship is do not exceed the limit of the capacity. There's a Q. Now the total mass of the boat and the load is boat and load. Boat plus load already is 1940 kg. Okay, density water 1000. Find the maximum buoyant force experienced by the ship. So A, you want to find the buoyant force. So using the formula V rho G lah. Okay. So here V rho G is totally related to the water. So volume part you submerge this one. Maximum line. So I just take 2 multiply 1000 multiply 9.81. So here I get the answer is 19620. Is it? 1000 multiply 9.81. 19620. B. Now they say got 2 person. One is a 60 kg, another one 70 kg. They intend to travel this one ship. Who is more eligible to be into the ship? So what is more suitable lah? So choose a 60 or 70, and then you need to find which one is the most suitable. You need to explain. So here maximum, I only can afford 19620. So that is floating. So I can say buoyant force equal mg. Now my buoyant force already 19620 maximum. Mg, I already got the load and the boat. That's a 1940 multiply 9.81. So here the question asks you how many weight you still can put in. So that plus another weight, the man weight. I can put how many? Okay, so after I minus how many? So continue. Weight of the man can go in is how many? Sorry, this one is a force. Yeah, correct. You want to put 9.81 outside also. This one is a mass. This one also mass. Then multiply. 588. 5, 6. So you can put there's a 588.6. Now I want mass law. Because they say 60 and 70, I go to divide. Mass 588.6, I divide by 9.81. 5 is 60 kg only. So only can bring the man that's a mass with the 60 kg. Already is a maximum. Now you can give the reason why. So this answer, man with 60 kg because total weight is not greater than maximum weight of liquid display. Liquid displays. So choose the 60 kg lah because after I plus together, the total weight is not more than the weight of liquid displays. So put 70 kg means already over. So over means you will sink already. Now we go to number 8, the last question. Object density. Object density. 40, they're using gram per cm cube. Mass 500 gram is immersed in a liquid density. This is the mass of the object. 500. Immersed in a liquid density. Liquid 2 gram cm 3. All using gram and cm cube. First one. They never say float lah. They just say immerse. We just settle just like the normal Archimedes principle. Immerse means the whole thing muscle. So the volume of liquid display for this one situation, VO equal VL. I never show the diagram how they go to immerse. They just mention object density how many. So you see the object density already 40. Object liquid how many? Only 2. Sure sing long. Is it understood what? For this one diagram, density object already more than density liquid. Sure, you go down. Go down means volume object equal volume liquid display. So here I can do my calculation. Volume object equal mass over rho. So the mass is how many? VO equal mass is a 500 over the rho also is a G gram cm cube. So I just 40. Final answer, I get it 12.5 cm cube. That's a volume object. You also can say volume of liquid come out. B, mass of the liquid display. Mass of the liquid display. So I know the volume liquid display. So mass liquid over density So here, mass of the liquid I don't know, but the volume I know, 12.5. Mass liquid over density for liquid is a 2. Okay, so after that, mass liquid is how many? 2 multiplied 12.5, that's a 25. So at A, I get B already. C, the buoyant force experienced by the object. G is a 10. Buoyant force, 0 G lah. Okay, V, so you know, 0 G, change become the Newton. So if using the volume is a 12.5, then V rho G. This one is for liquid. Everything for liquid. So V how many? V is a 12.5. City liquid, 2. Okay, you need to change. This one is a gram cm. Then you multiply again. The answer is for the 10, is it? Yeah. Next one, I change back, -3. Why I put -3, I just convert the gram become kg. 1.5 is cm cube. 2 is gram per cm cube. The cm and cm no more, but you still gram. This one is a gravity, but your answer still gram, is it? So if you want to convert, become kg. You borrow can using the gravitational acceleration is a 10 because SI you need. So convert, become kg, I divide by 1000. So final answer, what is my buoyant force? 0.25 Newton. Is it correct? 对吗？
对。
So already until example 8. Okay, the following is an objective question. So to finish the objective question, so when back to school, I just go to the application and also give you the answer for the objective. After that, you still got the bottom one with a structure question. This one structure question. Then finish. Any question? Ziyu, anything you want to ask?
没有了。
没有了，你给了啦。
没有咯，要多做练习嘛。
沈面有东西要问吗？沈面进and 沈面 go, anything you want to ask?
暂时没有。
暂时没有啦，读了就有啦。So hopefully you go to refer back what I'm talking about. After that, you borrow find out what the question you do, what the part you do know, and then you ask. So ask you now, you also don't know what is that because you never do any revision. So again, 有东西问吗？ Why object in water has different weight? 因为有 buoyant force support 它吗？你的 weight 肯定是向下的 ，buoyant force 是推你上去，所以你的 weight 就不一样了吗？一个下一个上要减了，所以你在水的时候你可以浮上来，你的重量也比较轻，因为你的 buoyant force acting to your body， 所以 buoyant force overcome 一部分的对，也可以这样讲。但是你整个人已经进去了过后 ，buoyant force 就不会再增加了。buoyant force 是跟住你的 level 下，你的 volume 下。一直在增加，但是如果整粒东西都已经在水就完了咯，你怎样再下都没有用啊，因为你整个 volume 都已经 display 了嘛 ，OK display 出来了 ，so that means the volume 就不会再增加咯，除非你一直下，你的 buoyant force 就一直加。Remember, buoyant force is totally talking about the V rho G 水的能，不是你的 object， 是水出来到底有多重。洪恩，东西要问吗？
没有。
So what you need to do, complete the tutorial, the objective and structure. And after that, you borrow find out you know or don't know. Melvin, Melvin wants some more. Last question, if convert G to kg, first then must multiply can and but answer not same more. 你换去10是吗？你换去 gram 去 kg， 你除1000，你说错嘞？不除1000吗？Melvin， 你变成 G 不 G 去 kg 不是除1000吗？那你除了1000，如果你再换去牛顿，你再乘9.81就不一样了。Last question So no question, so the record I will share. So that you refer back. After that, you do all the exercise. If you don't know, then go to school, then we discuss. So so say bye and see you on Monday for 5-3. Then the Wednesday 5-1. So your paper is still on the way. Don't be rushed on the way. So nothing, so everyone, 不会有期